The atom, a minuscule speck of matter, holds within its core a power almost beyond comprehension. This power, unleashed through nuclear reactions, can illuminate cities, fuel stars, and tragically, obliterate entire populations. Understanding how this power is harnessed, and the consequences of its use is paramount in our modern world. For millennia, humans harnessed energy from the sun, wind, and water. Then, we discovered the atom and unlocked a force unlike any other. This force, nuclear energy, stems from the very heart of matter, the atom's nucleus. It is a force that can be used for good, providing clean energy to power our world. However, it is also a force that can be twisted into a weapon of unimaginable destruction. The story of nuclear energy is one of scientific brilliance, political intrigue, and moral responsibility. It is a story that continues to unfold today, demanding our attention and careful consideration. At the heart of the atom lies the nucleus, composed of protons and neutrons bound together by immense forces. Nuclear reactions, whether fission or fusion, involve manipulating these forces to release the energy stored within the nucleus. Fission, the process employed in atomic bombs, involves splitting the nucleus of a heavy atom, such as uranium or plutonium. Imagine splitting a fragile object. When it breaks apart, energy is released. Fission is similar. Fusion, on the other hand, involves fusing the nuclei of light atoms like hydrogen isotopes to form heavier elements, a process that powers the sun. Fusion releases even greater amounts of energy than fission, but achieving the necessary conditions for a sustained reaction is far more complex. Both fission and fusion have revolutionized our understanding of the universe and our place within it. However, it is fission, with its terrifying destructive potential, that has cast a long shadow over the 20th and 21st centuries. Not all uranium is created equal when it comes to nuclear weapons. Naturally occurring uranium consists mainly of uranium-238, which is not easily fissile. To create a bomb, we need a higher concentration of the rarer isotope, uranium-235. This is where enrichment comes in. Enrichment is a complex and meticulous process that increases the proportion of uranium-235 in a sample. This process is technically challenging and requires sophisticated equipment and expertise. The enriched uranium, now capable of sustaining a chain reaction, becomes the fuel for a nuclear bomb. The enrichment process is a double-edged sword. On the one hand, it is essential for nuclear power generation, providing a cleaner alternative to fossil fuels. On the other hand, it is the same process that enables the production of nuclear weapons, posing a significant threat to global security. Imagine a single domino falling and setting off a chain reaction, toppling thousands more. This is a simplified analogy for the chain reaction that occurs in a nuclear bomb. When a neutron strikes the nucleus of a uranium-235 atom, it splits the atom, releasing energy and more neutrons. These newly released neutrons then strike other uranium-235 atoms, creating a cascade of fission reactions. This chain reaction happens incredibly fast, releasing an immense amount of energy in a very short period, resulting in the devastating explosion we associate with nuclear weapons. Controlling this chain reaction is crucial. In a nuclear reactor, control rods absorb excess neutrons, regulating the rate of fission and preventing an uncontrolled explosion. In a bomb, however, the goal is to unleash the full fury of the chain reaction. The detonation of a nuclear bomb unleashes a horrifying spectacle of destruction. The initial blast wave, traveling faster than the speed of sound, obliterates everything in its path. The intense heat generated vaporizes structures and people, leaving behind only shadows etched into the ground. Then comes the fallout. Radioactive particles, carried by the wind, contaminate the surrounding environment, posing long-term health risks to those exposed. The invisible poison of radiation can cause cancer, birth defects, and a host of other health problems. The aftermath of a nuclear explosion is a testament to the devastating power we have unleashed. It serves as a stark reminder of the consequences of nuclear war, consequences that extend far beyond the initial blast. Section 6, Hiroshima and Nagasaki, a stark reminder of nuclear power. The horrors of nuclear war were forever etched into human history in August 1945. The atomic bombings of Hiroshima and Nagasaki, Japan, remain the only instances where nuclear weapons have been used in warfare. The devastation inflicted upon these cities was unimaginable. Hundreds of thousands of people were killed instantly, and countless others suffered long-term effects from radiation exposure. The bombings of Hiroshima and Nagasaki serve as a grim testament to the destructive power of nuclear weapons and the lasting impact they have on humanity. These events should serve as a constant reminder of the immense responsibility that comes with possessing such destructive power. The memory of Hiroshima and Nagasaki should fuel our efforts to prevent such atrocities from ever happening again. Section 7. The Ethical Dilemma: Weighing Power Against Destruction. The development and use of nuclear weapons have sparked intense ethical debates. On the one hand, proponents argue that nuclear weapons act as a deterrent, preventing large-scale conflicts out of fear of mutually assured destruction. On the other hand, critics argue that the very existence of these weapons poses an unacceptable risk to humanity and the environment. The potential for accidental detonation, miscalculation, or intentional misuse makes the possession of nuclear weapons a constant source of anxiety. The ethical dilemma surrounding nuclear weapons is one of the most pressing issues of our time. It is a dilemma with no easy answers, requiring careful consideration and a commitment to finding a safer path for humanity. Section 8. The Path to Disarmament: A Shared Responsibility. The threat posed by nuclear weapons is a global issue that demands a global solution. Achieving nuclear disarmament, the complete elimination of all nuclear weapons, is a daunting task, but it is a necessary one if we are to ensure the survival of our species. International cooperation, dialogue, and trust are essential for making progress towards this goal. Treaties limiting the development and testing of nuclear weapons are a step in the right direction, but more needs to be done. Education and raising awareness about the dangers of nuclear weapons are crucial for building public support for disarmament initiatives. Each of us has a role to play in creating a safer world. Section 9. Conclusion: Our Nuclear Legacy. The discovery of nuclear energy brought with it both immense promise and peril. We have witnessed its power to heal and its power to destroy. The future of our planet hinges on our ability to harness this power responsibly and to work towards a world free from the threat of nuclear annihilation. The legacy we leave behind for future generations depends on the choices we make today. Will it be a legacy of fear and destruction, or will it be one of peace and cooperation? The answer lies in our hands.